Welcome to today's presentation on object-oriented programming in real-world applications. In this session, we will explore how OOP is used in large-scale systems and its role in industries such as banking, e-commerce, game development, GUI frameworks, and web development. Object-oriented programming or OOP is a design paradigm that models real-world entities as objects. It helps in managing complexity and maintaining large systems by dividing them into smaller, more manageable parts. By using OOP, developers can enhance code reusability, modularity, and flexibility. Key OOP features like inheritance, polymorphism, and encapsulation are vital in creating scalable and maintainable software solutions. Let's look at a banking system example. In an OOP-based banking system, we can model entities such as accounts, customers, and transactions as objects. For instance, the base class could be account with specialized classes like saving account and current account inheriting from it. Polymorphism will also useful here. Methods like deposit and withdraw can behave differently based on the type of account. This approach simplifies maintenance and allows easy extensions of the system. Next, let's im- let's let's examine an e-commerce system. In this system, we could have classes like product, order, and customer. These classes represent key entities in the e-commerce domain. Inheritance is useful for distinguishing between different user types such as customers and admins. Polymorphism allows actions like payment processing to differ based on the method chosen, such as credit card or PayPal. This structure supports scalability and flexibility in e-commerce applications. In this continued example of an e-commerce system, we see how various components interact. A cart class may manage adding and removing products, while different user roles like guest and admins interact with the system differently. For example, only an admin would have access to actions like deleting users or managing inventory. This illustrates the power of OOP to create a robust, scalable system where components are reusable and maintainable. Now let's explore an online learning platform. In this example, the system could have classes like course, student, instructor, and lecture. Inheritance allows us to have different types of users like students and instructors, both inheriting from a base user class. Polymorphism comes into play when methods like login have different implementations for each user type. This allows a unified approach to user management while accommodating different user behaviors. Moving on to game development, OOP plays a crucial role in designing game entities like players, enemies, and items. Each game object can be treated as an object with properties such as health, score, and position. For instance, you could have an enemy class with subclasses like zombie or alien, each implementing different attack behaviors using polymorphism. This structure is, also allows easy management and extension of game features as the game evolves. As we continue in game development, polymorphism allows for dynamic behavior. For example, different objects like player and enemy may use the same method such as attack, but the implementation will vary based on the object type. Encapsulation also plays a vital role as each object manages its own state, such as health or score, ensuring that the game logic is clean and well organized. Object-oriented programming is also widely used in GUI frameworks. GUI components like buttons, windows, and text fields are modeled as objects. These objects encapsulate their own properties such as position and size, and methods for handling user interactions like clicks or typing. Inheritance allows us to create specialized components such as submit button inheriting from a general button class. This makes it easy to reuse and extend components in the user interface. Building on the previous point, OOP allows for an event-driven approach in GUI frameworks. Components like buttons can handle events like clicks through methods that are defined in their respective classes. This modular approach allows for easy customization and extension. For example, we could have a button class with a clicked method which could be overridden in different subclasses for different buttons action. Object-oriented programming is also heavily utilized in web development. For example, in an online shopping system, we might have classes for user, admin, and guest, each with different permissions. Inheritance allows for the creation of specified user types, while polymorphism ensures that actions like login behave differently for each user role. OOP structures web applications in a modular and flexible way, ensuring scalability and ease of maintenance. Continuing with web development, OOP is crucial for creating systems like a shopping cart. In this system, classes like cart, product, and order are used to manage the shopping process. Operations like adding or removing products are encapsulated within the cart object. Inheritance allows different user roles, such as members or guests, to interact with the cart in unique ways, enabling personalized user experiences. As we wrap up, let's review the advantages of using OOP in large systems. One key benefit is modularity. Large systems are broken down into smaller, more manageable components. Reusability is another advantage as classes and objects can be reused through the system. OOP also promotes maintainability by separating concerns and keeping code clean and organized. Finally, OOP ensures scalability, making it easier to extend systems as they grow. To recap, object-oriented programming helps in structuring large systems in a way that is easy to manage and scale. It promotes code reusability, maintainability, and flexibility. By using inheritance, polymorphism, and encapsulation, developers can design complex systems that are easier to understand, extend, and maintain. Now, let's put the concepts into practice. Your task is to design a library management system. The system should include classes like book, user, staff, and library. Implement methods for borrowing and returning books, as well as searching for books. Use inheritance and polymorphism to model different user roles and interactions. Share your design with your peers for feedback. Thank you for your attention. To conclude, object-oriented programming is a fundamental paradigm that is widely used in real-world systems. By constructing code around real-world objects, OOP makes it easier to manage complex applications. For further learning, refer to object-oriented design and programming books and documentation. I encourage you to apply these principles to your own projects.